Right, today we want to talk about the properties of synaptic transmission. We're going to talk about 13 properties and david7santheatre@gmail.com. You can contact us, you can contact us for more and better videos at that channel, David7 Theatre. Yeah, so don't you forget to like us, subscribe for more and better videos, and share to other and fellow students to also enjoy the science we give. All we give is good. All right, let's continue. So we're first going to summarize these properties. We're going to summarize them because there are many. There are 13. We're going to summarize them. Then I'll explain each and every one later. So look at this. This is the first half, but we also have a second half here. So one-way conduction, that is the first property. Another one is synaptic delay, summation, which can be temporal or spatial. We have convergence and divergence. We have occlusion, all right. We have subliminal fringe effect. Those are 6, 7 remaining. We have facilitation, we have synaptic fatigue, we have synaptic plasticity and learning. We have reverberation, we have reciprocal inhibition, we have after discharge, and we have effect of acidosis and hypoxia. So basically, all these properties are properties of synaptic transmission. Yeah, there should be an error. Okay, so let's continue. We start right away with the first, that is one-way conduction. And the chemical synapse allows only conduction of an impulse from the presynaptic to postsynaptic neuron. In the recent video, I showed you how the synapse looks like. It has two membranes, that of a presynaptic knob and one of the postsynaptic neuron. So conduction takes place in only one direction, from presynaptic to postsynaptic, and never in the opposite. This is a law of Bell-Magendie, or what we call law of dynamic polarity. Okay, let's continue. It occurs because only presynaptic knob has the neurotransmitter, and only the postsynaptic knob has the receptors of the neurotransmitter. So that's the reason. We don't find receptors on the presynaptic knob, and we don't find neurotransmitter in the postsynaptic membrane, postsynaptic neuron. Okay, so that's the reason. Significance for this, it allows orderly conduction of impulses. Let's continue. That's the first property and it is done. Property 2, synaptic delay. There is a time lapse between arrival of nerve impulse at a presynaptic terminal and its passage to the postsynaptic membrane. This is usually 0.5 milliseconds. However, it should be less than 1 millisecond. Alright, so 0.5, that is half a millisecond. And the causes for synaptic delay, one is the time taken for, they are basically four here. So it represents the time taken for release of the neurotransmitter by the vesicles fusing and fusing. So that release exocytosis. That is one. Time taken for diffusion of transmitter through the cleft. That is the second reason. The third time is spent for the neurotransmitter to bind with the receptors on the postsynaptic membrane and cause opening of sodium ionophores. So that is the third reason, third expenditure of time. And the fourth one is the time taken for diffusion of ions causing changes in resting membrane potential, i.e. developing the excitatory postsynaptic potential or inhibitory postsynaptic potential. So that very time, these four courses of time, these four periods, they represent what is summated as 0.5 milliseconds, called it synaptic delay. And the significance of the delay, we can use that delay to estimate the numbers of neurons in a reflex arc. You know a reflex arc. So if you can see the time spent, now you can know that this one involves 7 neurons. It is polysynaptic, it is disynaptic, or it is monosynaptic. So this one is for monosynaptic. If it increases, you can know that there are just 3, there are a couple of neurons in that same reflex arc. All right, let's continue. Summation property of a synapse. That is the third property we're going to talk about. And in summation, a synapse exhibits the property of both temporal and spatial summation of both excitatory or inhibitory postsynaptic potential. And the significance of summation is that excitation of a single presynaptic terminal almost never excites or inhibits the postsynaptic neuron, as sufficient neurotransmitter is not released to raise excitatory postsynaptic potential to the threshold. You get this point? That a single presynaptic stimulation or excitation never excites the postsynaptic membrane sufficiently, because the neurotransmitter which is released by that single stimulation will not be enough so to raise the APSP to a threshold to fire an action potential. Okay, therefore, property of summation is essential for the stimulation of postsynaptic membrane, either by the simultaneous stimulation of large number of presynaptic terminals on a postsynaptic neuron, call it spatial summation, or by repeated stimulation of presynaptic terminal, call it temporal summation. You get this? Either by simultaneous stimulation of large number of presynaptic terminals on a single postsynaptic neuron, that is spatial. In temporal, you have repeated stimulation of a presynaptic terminal. All right, here I have couple of presynaptic terminals. Here it is one, but repeatedly stimulated. All right, let's continue. So the next one is convergence. We said convergence and divergence. So for A will be convergence. What am I meaning by convergence? You can see we have here, this is a phenomenon of termination of signals from many presynaptic neurons or buttons or terminals on a single postsynaptic neuron. As you can see here, have several buttons going to a single postsynaptic neuron, cell body, soma, or dendrites. Then we have this is convergence. Here we are having several sources, all right, still going to the single postsynaptic neuron. So that's the element I'm looking for, single postsynaptic neuron. So that is being convergence. Example are the ventral gray horn cells, which receive signals from several tracts of the brain. Yeah, that is true. Let's continue. So let's talk about divergence. Divergence can occur in the same tract, or it can occur in multiple tracts. And you can see in the same tract, we are having divergence, but in the same tract. Yes, same tract, as you can see here. But here we have divergence into multiple tract. It was a single presynaptic neuron which diverged and still formed a single tract. Here we are having divergence to form multiple tracts. All that is divergence. But in divergence, what we're looking for is that one presynaptic neuron may terminate on many postsynaptic neurons. That single impulse is converted into a couple of impulses. You get? So that is it. Yeah. So that is it. We're having a single presynaptic neuron going to divide and diverge into couple of impulses. All right. Let's talk about occlusion phenomenon right now. Now, occlusion, as you can see here, there is occlusion. There is something like an overlap at this point. So this overlap is the reason for occlusion. Let's describe it. In this situation, there is response to stimulation of two presynaptic neurons, which is less than the sum total of the response obtained when they are stimulated separately. If I have this presynaptic neuron, it is one and diverged, even this one diverged. So if you separate them, they will cause greater stimulation than when I stimulate them simultaneously in their nature within the body. So you can see there is an overlap which is causing occlusion. So occlusion is due to overlapping at afferent fibers in the central distribution, as you can see here. If it was single, we would get 10 impulses and 10 impulses, but after occlusion and overlapping, we get 15 impulses. All right. Number 6 is subliminal fringe. So in subliminal fringe, what we can talk about, look at this. Efferent neurons which are excited subliminally perform spatial summation, produce threshold stimulation. So if you look at this, we have neuron A and neuron B. Both are afferent, and these are the efferent neurons. So at the synapse, we are having stimulation of A and B. But A is in the discharge zone. The discharge zone of A is this. And we have a discharge zone of B. Alright, but we have some neurons in the central distribution which are stimulated subliminally. Okay, so because they are stimulated subliminally, this is not overlap. It is different from overlap. So this is just subliminal stimulation. Like it was meant to stay at 5, but it sends some other collaterals which are weak and cause subliminal stimulation of these two neurons here. These later summate and raise the threshold, which can be summated and raised to an action potential if it exceeds the threshold value. So it means we have subliminal fringe here. Due to subliminal fringe or subliminal stimulation, we shall get 12 impulses as a result within the afferent neurons. Okay, but if there was no collaterals sent to this region, the effect would be 5 plus 5, which is 10 impulses in the afferent neurons. Okay, so subliminal fringe effect. Subliminal means below threshold and fringe means border. Subliminal, below threshold, border, and the fringe means border. All right. So the response obtained by the simultaneous stimulation of two presynaptic neurons is greater than the sum total response obtained when they are separately stimulated. So if you separately stimulate these neurons, you get just 5 and 5. But if you find them in their nature and you stimulate these two neurons, they force collaterals to these regions, and the effect is 12 impulses. This is greater than the sum total response obtained when they are separately stimulated. Let's continue. Number 7 now is facilitation. So facilitation uh, is not a simple topic to talk about, but it is interesting that when presynaptic axon is stimulated with several consecutive individual stimuli, each stimulus may evoke a larger postsynaptic potential than that evoked by the previous stimulus. You understand this carefully. So one presynaptic axon is stimulated with several consecutive individual stimuli. Each stimuli may evoke a larger postsynaptic potential than that evoked by the previous stimulus. So the mechanism for this is that each succeeding stimulus increases the duration of action potential in the presynaptic neuron, so that the voltage-gated calcium channels can remain open for a prolonged period, liberating more neurotransmitter by exocytosis from the presynaptic neuron. All right. And normally, subliminal stimulus from a presynaptic neuron, call it a facilitator neuron, primes the postsynaptic neuron so that another subliminal stimulus can evoke a discharge from the postsynaptic neuron. Yeah, in the recent video, I talked about the facilitator neuron, which usually produces it is a third neuron which usually produces serotonin, call it 5-hydroxytryptamine. And when it is produced, it will prime the postsynaptic neuron so that another subliminal stimulus can evoke a discharge from the postsynaptic neuron. So that is facilitation. Number 8, synaptic fatigue or habituation. And when the presynaptic neuron is stimulated separately, I need you note these words. We have separately and we have stimulation as a whole. So within the body or when they are intact. But separately, we are separating it. So when the presynaptic neuron is stimulated separately, the rate of impulse discharge in the postsynaptic neuron is initially high. But within a few seconds, there occurs a gradual decrease and final disappearance of the postsynaptic response. And uh, this fatigue is temporal and modulates sensitivities of different neural circuits. All right, but the major thing is that there is ignorance of the stimulation. There is gradual decrease until postsynaptic impulse transmission disappears. Okay, let's continue. Fatigue or habituation mainly occurs due to exertion of the chemical neurotransmitter because at high rate of impulse transmission, the synthesis of chemical transmitter fails to keep pace with the rate of release. So that is the basic reason for that. However, you can also say that gradual inactivation of calcium channels, accumulation of waste products, and refractiveness of postsynaptic membrane to transmitter substance are other three causes of habituation. So you cannot stop at just this. You can add on more 3 points to be the causes of the habituation. We say that some waste accumulate. Calcium channels are progressively decreasing or being inactivated. And we also have refractiveness of the postsynaptic membrane to transmitter substance. Number 9, this is synaptic plasticity and learning. And in synaptic plasticity and learning, you can see plasticity refers to capability of being easily molded or changed. Synaptic transmission is flexible. It can be increased or decreased on the basis of past experience. Okay? So the changes in synaptic transmission can occur due to alteration at presynaptic or postsynaptic site or location. They occur at both levels, or one or both, but postsynaptic or presynaptic levels. And those are alterations. And these alterations, they will include post-tetanic potentiation, long-term potentiation, synaptic fatigue or habituation, sensitization, the opposite of fatigue, a long-term depression. So there's a video where I talked about plasticity. You will see the significance, where we find it in the body, and talk more about these 5 alterations which occur, and that is synaptic plasticity is in the next video. All right, let's continue. Reverberation is the 10th point. Reverberation causes reverberation is a property of synapses in which the impulse reverberates through the same circuit again and again. Okay, you can see this. If I have an input here, in the output of a synaptic neuron, there is a collateral which is sent back to the presynaptic neuron. So this activation of presynaptic neurons makes the impulse to reverberate around the same circuit. Okay, and you can see still it can be within the same presynaptic neuron, all right, or within the same postsynaptic neuron. That is reverberation. This is a phenomenon of passage of impulse from presynaptic neuron and again back to the presynaptic neuron to cause a continuous stimulation of the presynaptic neuron. So that is reverberation or back to back. Okay. So 11th property we can talk about will be reciprocal inhibition. So in reciprocal inhibition, look at this. You can see if I have this as the flexor muscle, call it the agonist or protagonist, and I have the antagonist here. In reciprocal inhibition, if I have impulses going to the dorsal root, or call them dorsal horn cells, all right, these ones activate the flexor muscle, but it also sends collaterals to the interneuron, which is inhibitory in nature, and this inhibits extension of the muscle. So this arc here sends collaterals to prevent extension of the muscle when flexing is occurring. Okay, because it will oppose flexion which is occurring this side. And we can talk about it that this is a phenomenon in which an afferent signal activates an excitatory neuron to a group of muscles and simultaneously activates an inhibitory signal or neuron to others, usually antagonistic muscles. So that is it. It sends a collateral which activates the inhibitory neuron, but it also activates the excitatory neuron. Alright, let's continue. The next property we can talk about is after discharge. In after discharge, uh, it is a phenomenon in which a single instantaneous input results in two sustained output signals, a series of repetitive discharges. That is what we call after discharge. It is from single, but you're having a series of repetitive discharges which are even sustained. And input signals, for example, for just 1 millisecond, can give output signals that last for a couple of milliseconds. And that is what we call after discharge. Input for 1 millisecond, the signal will last for several or many milliseconds. And we continue to our last property of neurotransmission. And that is called effect of acidosis and hypoxia on the neuron or synaptic transmission. The central nervous system neurons cannot sustain oxygen lack, and that is true. They cannot sustain hypoxia hypoxia. And synaptic transmission is particularly vulnerable to the effect of acidosis and hypoxia. Very vulnerable, okay? So in cases of this, transmission is affected. Alright, so I just urge you not forget to like our videos, subscribe for more and better videos, and share to other students to also enjoy the videos. They are good, very good. They are very good. Alright, you subscribe for more and better videos, you like us, and share to other students.